All right, over on the back page here, what we're asked to do is translate the following statements into coordinate points and then plot them. So this is using function notation here again, and remember that the number inside these parentheses is my x, or is my input, and outside on the other side of this equation, this is going to be my output, or my y. So if we want to create a coordinate that's associated with this, well, that's an xy coordinate, -1, 1. Over here for letter B, that's going to be associated with the coordinate 2, 7. Over here, f of 1 equals -1 will be associated with the coordinate 1, -1. And then finally, I get this coordinate 3, 0. And I can plot all these points. Remember, the x-axis is my input, and the y-axis is my output. It's trying to look like an arrow. So I can plot all these points just like I would plot any coordinates here. So -1, 1, that is my letter A. Letter B, I have 2, 7. 1, 2, 3, 4, 5, 6, 7. I have point 1, -1. And finally, 3, 1, 2, 3, 0. So let's just label these real quick. Here is A, B is here, C, and D. So you'll notice this thing also passes the vertical line test. That's why it's a function, and that's why it uses function notation. So here I'm taking inputs and outputs, creating coordinates out of them, and going to a graph. In this next example, though, I can go the other way. Here I'm given a graph, and I want to figure out the outputs for the given inputs. If this line here, or this graph, is my function f. So it says that this function f of y equals f of x is this graph below. It's called a piecewise linear function because it's made up of straight line segments. This part you don't have to worry too much about, but what we really want to get after here is figuring out what our outputs are for these given inputs. So let's take a look at the first one here. It says find f of 1, and what that means is that I'm looking for what my output is when my input is 1. So that means I'm going to have to look along my input x-axis, and I'm going to find 1. That's my input, and now I need to follow up to the graph where my output lies. And this point right here is going to be where my output is, where my x is 1. So that looks like something. I'm going to get a 1, 2, 3, 4. So that means that f of 1 is equal to 4. And that should also make sense since it's associated with the coordinate 1, 4. So why don't you try looking at these others, f of -3, f of 5, f of 0, and you can skip ahead and see if you got it right. And of course, I'll go through these myself here. For f of -3, I'm going to follow my x-axis, 1, 2, 3, to where x equals -3. And I'm going to trace it down to 1, 2, 3, 4. That means that when my input is -3, my output is -4. For f of 5, I'm going to look for my input of 5, 1, 2, 3, 4, 5, and find where my graph is for the output. It's at -1, -2. So f of 5 is -2. And finally, f of 0 is going to happen when my input is 0, and my output for this graph is at 2. All right, so again, remember all of these points are associated with coordinates, and which would then relate back to function notation pairings. We can also go the other direction, though, and we can now be given an output and have to find the input. So this one's going to be a little bit interesting, a little bit different here. And here's what we're going to see. For f of x equals 0, remember this is where I'm looking for where my output is 0. So if f of x equals 0, that means that my output is 0. That means that my y value equals 0. So now this is where it gets a little bit different. I'm going to follow my output, which are my y values, and I'm going to see when my y value is going to equal 0. So I see at this point, and at this point, and at this point, I have a y value of 0. If I were to grab each one of these coordinates, that y value is 0 for each of these. So that means that I have multiple inputs that produce this given output. So x can equal a set of numbers, and I'm going to use the squiggly bracket for set notation. X can equal -1. X can equal 1, 2, 3, 4. And x can also equal 4, 5, 6, 7. So there are 3 solutions that would produce an output, or 3 inputs rather, that would produce an output of 0. These are a little bit trickier. So again, you can try and skip ahead if you want to try this one on your own. I'm going to go over this one now. If I'm looking for an output of 2, I'm looking for when my y values equal 2, and I see 1 here, and I see 1 here. So the x values that produce an output of 2, x can equal 0, and x can equal 1, 2, 3. So these are a little bit trickier. Remember, it's okay to have multiple inputs that produce the same output, as long as I don't have multiple outputs from the same input. So this is all okay here. This is still good. And you can notice our graph passes the vertical line test. So finally here for letter C, it asks what is the largest output achieved by the function? And we can see here that's kind of my maximum. There's no point. This is like the peak of the mountain. There's no point higher than right here. The largest output would be whatever the y value is. So 1, 2, 3, 4 is the largest output, and that occurs at the x value of 1. So how we would denote this is that at f of 1, I get my largest output, which is 4. So what I want you to do next is, how about you try these down here? It's the same type of process. Now you're given a little bit curvier of a function here, but the same thing. I want you to find the outputs for the given inputs, and then we're going to do one where you're going the other direction. So I want you to give those a shot and skip ahead and see how it went. All right, so for g of -2, I'm going to look for my input of -2, and here's my output at -1, 2, 3. So g of -2 is going to equal -3. For g of 3, I'm looking for an input of 3, and I have an output of 1, 2, 3, 4. G of 0, I have an input of 0, and I'm going to go down to find my output of -1, -2, -3 again. And finally, g of 7, let's follow the x-axis to find my input of 7. 1, 2, 3, 4, 5, 6, 7. And it looks like that output is at 0. So those are my outputs for the given inputs. On to letter B here. What values of x solve the equation g of x equals 0? So I'm going to look for along when y equals 0, which is also my x-axis, wherever my graph crosses y equals 0. And I see that happen in 4 different spots. So the x values that would solve this equation, or that would produce an output of 0, are given by the set x equals -1, 2, 3, when x equals 1, when x equals 2, 3, 4, 5, and 7. So all of these x values as an input will produce 0 as an output. And we call these zeros of a function. And we'll talk more about that later on, but something to keep in mind. Finally, we're asked how many values of x solve the equation g of x equals 2. So that means that I'm looking for when my outputs equal 2, or when y equals 2. And that's going to happen 1, 2, 3, 4 times. So I will have 4 solutions, or 4 x values to this equation. And there you go. Hope this helps.